And welcome everybody to the Daily Space Weather. We're looking at the Solar Dynamics Observatory colorized magnetogram here to see only two sunspot groups. Just two. They're both alpha class. This one up here and this one down here. The likelihood of major solar flares has gone down quite a lot. The likelihood of a coronal mass ejection is still there. And our patrons were informed of this last night. We've actually advanced our coronal mass ejection watch to a coronal mass ejection warning. There's a lot of filamentary material in between the sun and the earth. So here's a composite image. Colorized magnetogram and ionized iron in 171 angstroms, part of the UV spectrum, ultraviolet light. And here's 304 angstroms ionized helium, which is the best wavelength at showing filaments. I would note filaments down here, over here, over here. You can see some prominences over here. Lots of filaments between the Earth and Sun right now. Let's zoom in a little bit on the equatorial portion. Spectacular view there of ionized helium. And next I'd like to cite our mission. So part of our mission number 2 is to raise the awareness of the general public of the relationship between space weather and Earth effects. You can read more about our mission at smashamash.com/forum/mission, smashamash.com/forum/mission. It's all free at the moment. And next I'd like to thank our patrons, the real source of funding for this content. So thanks patrons. You're increasing the probability that these videos will remain free, publicly visible, and in existence, I'll say. Patreon.com/smashamash for all the earliest alerts. Thanks again to our patrons. They're listed in order of total lifetime contribution. So please consider becoming a patron if you're watching the videos, especially on YouTube. Patreon.com/smashamash. Let's do a cosmic ray report. We're going to look at the Apatity Neutron Monitor, Barentsburg, Athens, Mexico City, Oulu, and 2 Antarctican monitors. So there's Apatity. You can see a bit of a downtick here over the past 30 days there. A little slight downtick at Apatity. How about Barentsburg? These are 2 very far north neutron monitors, by the way, and there's Barentsburg also ticking down over the past 30 days. Next, we'll go much farther south to Athens, Greece. There's a 30-day chart of Athens, Greece. More flat here on the past 30 days there. Let's go even farther south to Mexico City. And you can see a bit of a downtick there at Mexico City over the past 30 days as well. And keep in mind, Mexico City is one of the ones that you can access the archival data from. Yeah, Earth is not at its cosmic ray maximum. That happened around 2009 or 2010. Next, Oulu, Finland, going back very far north. And then as far south as we can get, we'll go to Antarctica. Here's Oulu, Finland. Downward trend over the past 30 days at Oulu, DOMB, Antarctica. Downward trend at DOMB, Antarctica over 30 days. And DOMC Antarctica, downward trend there as well. Next, a diagram of the solar system. Here's where stuff is now, as Jupiter and Saturn dominate the night sky. And we've advanced that 1 week to August 2nd. There's where things will be on August 2nd. And we've brought back our in-the-sky chart. I don't know how it got off of the coverage, but there's a chart of the sky. And if you're out before dawn, you may see Jupiter and the moon very close to each other, just off the ecliptic there. Also Saturn moving into a setting mode here in the southwestern sky right now, where I'm located here in Lehigh Valley, Pennsylvania. The radial flux has dropped down to 82 as we see sunspots degrading, a reduction in the likelihood of solar flares. Although there is a coronal mass ejection warning once again in place. So here is the radial flux over a year. That's the Solon.info chart for radial flux. Solon.info/solar. The black line is the radial flux. The red line is the sunspot number. And look at the way it's dropped off a cliff. We've only got two numbered groups right now. And again, the radial flux now down to 82 solar flux units. There is a forecast for geomagnetic unrest there. I believe that's for a coronal hole wind stream, although we don't have a very well-defined coronal hole. Let's look at more data like global seismicity. As the 7 magnitude earthquake drought continues, we're pushing the 90 days without a 7 magnitude quake here, folks. So only one over the past 90 days. And going back to 2020, you can see how many 7 magnitude quakes happened then, how many happened in 2019, and how many happened in 2018. And yes, the second half of the year was extremely active in 2018. The last 90 days, quite inactive. And indeed, the past 24, not that active either. I think the largest was this 5.8 in the Kermadec Islands there, north of New Zealand, around the Kermadec Trench. There's a deep quake at Japan at a 4.0. Magnitude over 500 kilometers estimated depth. Some aftershocks there in the Kermadec Islands region, a 5.3 and a 5.1. And if we forget to cover anything on the earthquake list, leave us a comment and let us know. We do read all of our comments, folks. We apologize if we can't respond to all of them. Also a deep quake at the Fiji Islands there. So some activity there happening north of New Zealand. Probably the biggest hot spot on Earth right now for earthquakes. A deep quake at the Kurile Islands also. A deep quake south of Fiji. Japan saw a 5.1. In Indonesia, the second largest of the past 24 was a 5.7 magnitude quake there. Tonga also saw a deep quake just happen here earlier this morning on July 26th at 6:29. A deep quake there of 4.8 magnitude. And some small quakes there in California as well. Volcanoes. We're wondering what volcanoes are erupting. And indeed, Karimsky now on the list. As it explodes, it's producing a 10,000-foot plume of ash over the Kamchatka Peninsula. Shiveluch, on the same peninsula, also exploding, 14,000-foot ash plume there. Subanose Jima, flight level 100, that's a 10,000-foot ash plume over the Ryukyu Islands. Fuego exploding, producing a 15,000-foot volcanic ash plume. Nevado del Ruiz exploding, 20,000-foot ash plume. Sangay exploding, 20,000-foot ash plume. That's in Ecuador, by the way. Revenador in the same country, flight level 150, as the Revenador volcano produces a 15,000-foot ash plume over Ecuador, Peru. Intermittent emissions as it explodes, 23,000-foot ash plume, and we're unable to detect Nevados de Chilean. Please do not attempt to do a Steve Stimpak and pole vault the caldera. It could be unfortunate. We need the YouTube views. Also, we need you to share the content. And one more quick note about volcanoes. Shout out to Kurt Begemon. Yes, the South African cyclist made a trip to Iceland to do a gravel race, and he went to visit Fagradalsfjall. So here is some fresh lava from Fagradalsfjall, compliments of Kurt Begemon. Thanks for tuning in, and thanks for the photos. Here's some more photos for you, a little farther away from that fresh lava there from Fagradalsfjall, and you can see some of it is spilling over the crater valley here. Fagradalsfjall is interesting because it is a cinder cone that filled up its entire crater valley and is now spilling into neighboring valleys. It transformed from a cinder cone to a shield volcano before our very eyes. Here's a close-up of the lava. Just fantastic. Thanks again, Kurt. And if you're on Instagram, make sure you follow us, smAsho, as well as Begemon Racing. And we'll actually feature those images at a later time on our Instagram feed. Kurt was wise enough to not attempt to pole vault the caldera. Neither should you. This public service message brought to you at massive personal risk and expense from smAsho.com. So visit our links and support our channel via the links in the description below this video. Next, looking at the GOES X-ray flux, no major flares here over the past 3 days. There was a large C-class flare that's just about to leave the end of the graph there, just about 3 days ago from when we made the video. No proton strikes here, no coronal mass ejections headed our way yet, although there again is a warning. One is about to occur. It's probably going to be pretty minor, and whether it's facing the Earth or not, I doubt it, but we have to forecast it when we see it about to happen. So here's the GOES magnetometer over the past 3 days, and the Earth has just recently moved into a South Pole-oriented current sheet. We'll show you that in the next slide. And these sawtooth patterns here in the past couple of days were caused by the indecision for Earth's potential field surface source line. So here's the top view ecliptic plane field plot. And you can see Earth's orange line there, that potential field surface line from planet Earth, now in the South Pole-oriented current sheet. It looks pretty small. There could be another North Pole current sheet just around the corner here. But for the moment, South Pole current sheet is the Earth portion of the current sheet polarity, if that helps. I doubt it does, but anyway, that's what's going on in the heliospheric current sheet polarity. Just keep in mind, this is not to scale, folks. Here's a line of sight view of the same data, showing you sort of a three-dimensional view of the heliospheric current sheet, made up primarily of solar protons, hydrogen nuclei, which are the main component. About 90% of the solar wind is comprised of hydrogen nuclei. This also shows you the solar magnetogram. Quite a bit of magnetism here on the Earth-facing portion of the sun, despite low sunspot numbers. And our regular viewers are aware that we don't need sunspots or solar flares to produce coronal mass ejections. So here we see a South Pole-oriented current sheet here. It's pretty diffuse, and it's also getting some mixture with some North Pole-oriented coronal hole activity here. This coronal hole plot also shows you the sun's B field in blue. So a bit of chaos regarding polarity going on. And the solar flare monitor is kind of all over the place right now. It's showing all kinds of little active regions there. So don't be surprised to see a radio burst and a coronal mass ejection when it releases. It's sort of already in the process. I have a feeling it's going to be a low-speed coronal mass ejection, but in any case, there's the solar flare probability. I think it's a little bit high here at the end, as we don't really see any significant likelihood of new sunspot groups forming. So a little bit of magnetic activity must be going on there for the flare probability to get that high. KP index, a measurement of global geomagnetism, only at 1, KP1, and only a KP of 1 or 0 over the past 24 hours. Calm geomagnetic conditions. Next, the real-time solar wind. And we see some anomalously low readings here. When we get below a 1 proton per cubic centimeter for the solar wind density, the automatic error bars show up. So you see these red and yellow lines down here. Those are likely errors, at least according to the program. We also do see a signal here changing with the plasma temperature and the speed. So I have a feeling this one is actually legit data. There was a shift in the phi angle just before this little signal happened, and it looks like that is now subsiding. Anyway, current conditions are just under 5 protons per cubic centimeter for solar wind density. Solar wind speed only 325 kilometers per second, essentially solar minimum conditions. Next, looking at magnetohydrodynamic pressure. It's our Geospace Magnetosphere movie, 4 hours of data. Is the Earth's magneto causing fear? Well, hopefully not. It's just a Geospace Magnetosphere movie. And you're looking at nanopascals here surrounding planet Earth. Pretty weak magnetosphere right now. Not a lot of magnetism by induced radiation from incoming solar protons and their breaking radiation, otherwise known as Bremsstrahlung. Yes, the breaking radiation, Bremsstrahlung. Here are ground magnetic perturbations. Geospace delta B changes to Earth's own B field. We showed you the sun's. Here are the Earth's B fields. And we'll let this play through as it's refreshing. It would be refreshing if it would just refresh. We'll let it play through a second time here as we try not to edit the videos in order to get them onto your screen as quickly as possible. We do see some magnetic pulses coming out of the Pacific Ocean here, nothing too major. And of course, most geospace delta B occurs at the poles. That's 4 hours of data, just like the last Geospace Magnetosphere movie. By the way, I'd remind you to press like and subscribe if you're new to the channel. Tell your friends, foes, science noobs, and science pros about our content, and congratulations on finding its existence. We're impressed that you realize that we exist. We're also on BitChute. There is a 500 subscriber BitChute exclusive somewhere down there in the list. There it is. It's got me in a waterproof boonie hat. And we also do regularly stream to Twitch thanks to our followers over there. Today's cosmology segment will be integrated into the daily space weather video. Just keep in mind that not all of our cosmology segments are. In fact, yesterday's was a separate video. So check our playlists, youtube.com/smashamash/playlists. There are over 200 videos in our cosmology segments playlist. Let's get to it. Yesterday we talked about the Vela pulsar in some pretty significant detail. If you weren't aware of what the physics of that are, well, go check out yesterday's cosmology segment video. Today's astronomy picture of the day is CG4, a ruptured cometary globule. It's not really a cometary globule, folks. It's actually, there's actually a star in there. I believe it's this right here, that little bright spot there. I think that is the star. And it's not really understood what caused this ruptured-like appearance to this. If it's perhaps some kind of a interstellar wind stream or something causing that to behave in that fashion, or if it's some sort of intrinsic properties of the star, or maybe it's a combination of the two. Ultimately, we don't know. And by the way, this galaxy is very, very far away and has absolutely nothing to do with this foreground cloud here, CG4 ruptured cometary globule. That's apod.nasa.gov, the astronomy picture of the day. And let me just talk about a brief correction. Yesterday, I idiotically talked about Uranus, when actually the astronomy picture of the day yesterday was of Neptune and Triton. So I was talking about the right moon and the wrong planet. For some reason, I thought I was talking about Uranus, when actually this photo from Voyager 2 in 1989 is of Neptune. So Triton is the ethane-based moon of Neptune, not of Uranus. So I apologize for that. That's my little retraction for yesterday's deep dive into Greek mythology about Uranus, although I got to say, it's still pretty interesting. Of course, Neptune has completely different Greek mythology, and you have to ask yourselves, how did the Greeks even know about the existence of Neptune? But in any case, they did. So we're not going to pick any random numbers or anything today. That's our brief cosmology segment. Let's get on with the daily space weather video to talk about electrons. Earth is surrounded by bands of them, and they're not causing any charging hazards with satellites at the moment. Here's the 1-year chart of it from Solon.info, and here's the 3-day chart. Once again, 2 days in a row, we nailed the forecast, and NOAA was incorrect. So there's a 3-day chart of electron flux. And these last 2 yellow diamonds were my forecast, not NOAA's. NOAA was down here, and I was right. NOAA was wrong. Cheers. I won't continue on with this because I'm not sure about this one. This could be correct, or we could see level amounts. I don't expect to see higher levels here. I expect to see the current electron levels subside a little bit, so I would tend to agree with NOAA on this forecast. That green box is the forecast. And here's a diagram of Earth's Van Allen belts. Feel free to pause the video. Here is the total electron content. So now you're looking at the electron density through the entire air column up to your GPS satellite, all the way down to your handset. An area of tens of thousands of miles. And we'll let it play through a second time as we're seeing a little bit of chaos here. No extreme anomalies, but some chaos here in the southern Indian Ocean. Some surprisingly high density levels of electrons. High electron densities there. Right around this area here. It's pretty minor though, and this does give accurate ideas of how much GPS error you'll receive. It's a reason to turn on location accuracy if you're using a GPS. Location accuracy will use Wi-Fi to attempt to get a better location for you. Here's another diagram of the atmosphere. It shows you thermosphere temperatures, electromagnetic radiation penetration, and layers of the ionosphere. Next, we're going to look at the F layer, one slice at around 300 kilometers. Here's the last day of ionosphere. And so far, it's looking a little bit more normally than it's been in the past couple of weeks. And the vibrational frequencies of molecules in the upper atmosphere, the bridge between space and Earth, known as the ionosphere, gives us insight into Earth's magnetosphere. So this data is from Bureau of Meteorology from Australian government. Some anomalies here in the southern hemisphere mainly. And we'll bring up the latest image. There it is, 8:30 Universal Time. You can see a little anomaly here in the, once again, the southern Indian Ocean. That image from 8:30 Universal Time. And we're going to do a meteorology segment today. It'll be a separate video. Make sure you check our playlists once again, youtube.com/smashamash/playlists. All right, so another spectacular meteorology segment. Make sure you check that out. Today's is a separate video. Here come bonus features in the form of the ElTiday Spain ground-based observatory. So you can see filaments up here, mainly a little bit east longitude. Filaments. This one here may be shaped like Moloch's horns. I don't know. I'm very, very frightened of that. It's like an M shape. It's very scary and spooky. This data only 3 minutes old here from the ground-based solar observatory in ElTiday Spain. Next, the high-resolution intensitygram to show you weak sunspots. That is an alpha-class sunspot. There may be another group forming behind it. This is now an alpha-class sunspot as well. Here's the colorized magnetogram. So once again, intensitygram, magnetogram, alpha-class sunspot. Alpha-class sunspot. We've only got North Pole-oriented umbrae right now. And only 2 named sunspot groups. It looks like for today they're degrading promptly. Likelihood of solar flares has gone down. Likelihood of coronal mass ejections nearly 100%. Here's the GO16 SUVI thematic map. And you can see all those bright orange areas in the middle there. Those are all filaments. And some of those are about to eject. Mark my words. Here's 1700 angstroms. This is just part of the extreme UV spectrum. And we'll show you one more SDO video before we close out today's daily space weather. So here's one more video from the SDO Browse Data Center. It's 3 different ionized iron ultraviolet emission spectrae, 335, 193, and 94 angstroms. We'll zoom in a little bit before we close out. Thanks for tuning in to the Daily Space Weather. Once again, congratulations on realizing our channel exists. Tell your friends and foes about the content. Press share on your social media. Leave us a comment. We'll see you next time. And may that solar wind be at your back.